So our laboratory is an independent one with private funding. We're not a university because over the years we've asked questions outside of the box. And as you'll see today, we continue to do that. And we've just begun exploring the kinetics of the exclusion zone. I'm going to discuss some of the beginning observations and then turn it over to Harry, my partner, who's a physicist and engineer who designed and developed a device to really study the exclusion zone phenomena in a flow cell with very reproducible quantitative results. And then I'll discuss the results that we obtained working with human subjects, in part aiming to influence the size and the kinetics of the exclusion zone. Meantime, we have other things looking at vortices and effects of vortexing on the water, as well as the effect of ionizers. Having spoken about ionized water last time, we've taken that into the exclusion zone to see how it affects things. So our research questions are as follows. What do microscopic observations in more depth tell us about the exclusion zone phenomena? Does the easy change in response to various influences, including water, alkaline water from an ionizer, that's water from the cathode region undergoing partial electrolysis, the effect of vortexing and magnets, and the effect of human intention to try to speed up or slow down formation of the exclusion zone, or send putative energy, which has been called chi or prana, many other names by the various indigenous medicines around the world. What does high voltage photography, electrophotography of the activated water reveal by comparison using the gas discharge visualization camera developed by Dr. Konstantin Karatko, who's with us, and a speaker here? And does absorbance at 270 nanometers change after activating water? So those are the questions, and I can't present all of our observations, but just bits and pieces. First, the microscopy. This is a typical photo that you would see in Dr. Jerry Pollack's and his colleagues' work, looking at naphthalene as a charged membrane, a wedge in the upper right-hand corner here, with laboratory type 1 water that's ultra pure, which has very high resistance, and using 1 micron amidine polystyrene microspheres. And after about 6 minutes, we do find a typical exclusion zone ranging from about 0.4 to 0.6 millimeters. There it is. And you see the beads as a kind of gray area around that, the corner of the naphthalene. We've also looked at some other things with interest, curious about the difference between raw and pasteurized homogenized milk. We looked at raw milk, inserting a naphthalene wedge. Immediately, much of the fat particles were absorbed by the naphthalene, turning it bright white. And then we found an interesting pattern around the corner there. Of course, the particles here are a very mixed bag of different sized fat globules in milk, ranging in size from probably 0.1 micron to about 10 microns in diameter. So it's a very heterogeneous colloid. And closer to the naphthalene wedge, we see this very distinctive pattern. It's very reproducible, and it's very different from the usual exclusion zone. And it seems to have these processes, which seem to occur in pairs, as well as an exclusion zone of the fat globules, a couple of different exclusion zones, but definitely a pattern formed by the colloidal fat particles within the milk, which is very reminiscent of something from plasma physics called Birkeland Currents and filaments, which form in plasmas on cosmic scales as well as smaller contained plasmas in the laboratory. And there's a small but growing literature of looking at the colloid as a kind of cold plasma consisting of charged particles that I found very interesting. Here is some examination under dark field microscope of looking again with a laboratory type 1 water, which is ultra pure with a naphthalene wedge, that's the dark area here. 1 micrometer carboxylated polystyrene microspheres, which appear white in this case because we're looking at dark field. And you can see a dark, clear area exclusion zone close to the naphthalene, but there are also some processes, some aggregates of polystyrene, which are very interesting, I'd like to point out, that seem to have not been discussed before. So there's a very clear zone, and then there's a secondary zone that's not quite so clear. But you can see the B front, which is very bright at some considerable distance from the Naphion. So there's a more complex structure to the exclusion zones that haven't really been discussed much. And here is, under bright field, a smaller 0.5 micron carboxylated polystyrene microsphere used, a wedge of Naphion. You see the exclusion zone is a very thin, clear layer here because the size of the particle seems to indicate a different size exclusion zone. And then we see a darker area where a lot of the colloidal particles are aggregated, a secondary clear zone, a secondary deposit or a cloud of the particles again, and yet another clear zone, and a final front. So there's a lot of complexity to the structure. We also looked at uncharged colloidal particles. Silicon dioxide interested us because it's, along with water, the major component of the Earth's crust. It's also amphoteric, as is water, and we got the most interesting phenomena looking at 1 micron silicon dioxide microspheres in ultrapure water with Naphion. Not only did we get an exclusion zone, which was small, but we got a lot of ultrastructure at that, and we got the growth of dendrites. The Naphion is in the upper level here, and you see a growth of the silicon beads stacking up in filaments, literally, over time, forming structures that look lifelike, but of course they're not. And I have a video here. Let's see if I can start it. Oops. Let's see. I'm going to do this. So I hit the mouse twice, but I can do it. You know how to do this? Okay, I'm going to have to go out of this. I have it also on the desktop. I did. There it is. Moved. Okay. Yeah. So this is some video footage. You can see a very small, clear zone. This is an Naphion. But as you'll see under higher power, a lot of, you notice these are also migrating toward the Naphion. So this is the interface, and it's highly active. It's almost lifelike in its level of energetic transactions going on. And some levels of magnification, you see microspheres moving toward the interface, and others you see them moving out. There seems to be a three-dimensionality to a dynamic self-organization that's taking place in the exclusion zone. And different levels of it. It has a secondary front, and there's the interface or the size of the exclusion zone. And I'm focusing at different levels here. Now notice the silicon particles in this area as you'll see a definite movement toward the interface as I get to a certain magnification. Well, they're moving rather en masse. And it's almost like this is an attractor and the bees are going for the honey. Other areas of magnification, you will see a clear zone where that is not happening. So it's only in certain planes of focus of the microscope. So in this area, it's invisible, and as I focus further down, it comes back. So silica produces the most phenomenal, dynamic-looking interfacial zone of all the materials that we examined. And that's probably not an accident. Let me go back to my slideshow now. Let's see, because it's just starting over. So we see that upon looking with a more powerful microscope and focusing in on different planes, we see a dynamicism and a level of self-organization that's characteristic of the exclusion zone. Here's another video. I have to go out of my slideshow. It's dark field, it may be more obvious. This is 1 micron carboxylated polystyrene. And the ultra-pure water and the naphthalene is over here. Already there's a kind of front that is formed, but notice the march of many of the microspheres toward the interface, and also an aggregation of microspheres here. These are both negatively charged because the naphthalene has sulfated groups on the outside, and these are carboxylated polystyrene microspheres. Another thing that has also happened with these is, it's not visible in this plane, but you'll see in a moment, the growth of filaments. And I'll focus on that in a second here, as I proceed downward. The density of these microspheres is close to 1, the density of water, so it's not a gravitational issue, I think. That of silica is about 2, but in hydrodynamics of small objects like micron-shaped microspheres, it's viscous drag that's much bigger force than gravity. And of course, electrostatic issues. So there seems to be 2 fronts of the beads, and then aggregation and the formation of these processes which move outward. And I'm focusing in on that part now. It will become clear in a second. It's surprising to me how dynamic this region is. If that water is so crystalline, are we looking at an artifact of beads moving, which are they part of the exclusion zone or simply indicators, or are they interfering? These questions come up for me, but here the processes are almost dendritic growth of microspheres at the exclusion zone area. Let me go back to the slideshow again. So just to show you this in a time sequence quickly, focusing on the different planes from the top to the bottom. Watch carefully. I'll go through this and you'll see these are the focal planes and how you see those particles move in a time-lapse photograph. So our proposed diagram of flow as we observe it at the interface, and interestingly I saw virtually the same slide that someone did on the poster out there. Interesting. We have the system sandwiched between the glass slide and the cover slip. This is a cross-section with a piece of naphthalene. The microsphere suspension is out here in water, and in the different planes we see movement, and we believe that this is a 4 or 5 body system because we have glass, naphthalene, bulk water, easy water, and also microspheres. It's a very complex system. And perhaps the positioning of glass adds to this whole system of studying the easy in this kind of sandwich optical way. But it does show that there is an exclusion zone that seems to be maximal in the center. And if you use a microscope that's more coarse and not as fine, then you miss the other details of it. So, I'd like to introduce Karen, who will now discuss the device that we built to study in detail. This is my partner and fellow scientist.
Thank you, Beverly. I just wanted to say something about the complex system that Beverly just described, where we had a glass slide, an aphium, and another glass slide. Initially we had some experiments done where we had a glass slide, aphium, and then plexiglass. And we found that that did not give us much of an exclusion zone at all. So from that we knew that plexiglass and glass are two completely different systems, and we had to stick with glass. And later we determined that it is probably because glass is silicon dioxide and has an amphoteric surface. That's what we need. Okay. We wanted to study the system more quantitatively, and immediately it became clear we needed a process where we can reset the system, meaning starting from an easy layer of 0 and then watch it grow, and then hit the reset button again, whatever that may mean, and start from 0 again, so that we could get a quantitative analysis of how the easy layer would develop over time. And so we figured we needed a flow cell, and that's what we designed. And here's a brief description of the system that we machined and fabricated. We built our own home-built structure here. And here you see we have a sandwich of a microscope slide. We have Dafion in between, it's very difficult to see. And then we have another slide on top of it. Here you see an inlet, that's the hole that we drilled into the bottom slide, and here's another hole, that's the exit. So we come with water in here, come from the bottom, it goes between the two slides, and then out here, and we have a recirculating pump here that can do the recirculating. Our reset button was basically starting the recirculating pump, recirculating pump, and then stopping the pump. So during the recirculating, we had mixing and so forth, and an easy layer could not build, and as soon as we stopped the recirculating pump, then the easy layer could form. And so that gave us very good reproducible results. Here's a little bit more detail. Here you see a side view of the system. The two slides are basically in here. This is the inlet, this is the outlet here, and our recirculating pump. That's the system, and we have an electronic, we have a digital camera here that looks down into the system. We illuminate here with light guides. It flows, comes from the bottom of the light and then goes through the two slides and then into the microscope. And we have a digital acquisition system here. This is a comparison between tap water and alkaline water that we got from an electrolyzer that we hooked up to our tap water. And here I will show you a time lapse. Right now we're at 20 seconds after the reset, and you can see this here, the dark edge, that is the Nafion water interface. And here we have a small easy layer forming. And watch at the here we have, on the left side, you have the tap water, and on the right side, you have the alkaline water. So, as I go through the slides now, watch carefully how the easy layer develops differently on this side versus this side. So here we are at 20 seconds. Now this is at 1 minute, 2 minutes, 4 minutes, and 6 minutes. And you can see already, here on the left side, we have a dark area here, but we also have a gray area here. And it is completely different from this side here. And we analyzed it a little bit further, and we believe this is the result of the three-dimensionality that we see. So we believe that the easy layer is being pushed out all the way here, but here we see the projection that is sticking to the glass slice at the bottom and at the top. And here we reproduced it with tap water versus the pH 10 buffer, because our alkaline water was 9.5 pH, and initially we thought it might be a pH effect. But here we can see it's not a pH effect. So it really had to do with the alkalinization of the water. So we believe that I have to say, the pH buffer, one can get a high pH because of ionic strength or because of excess of electrons. And so we believe that there's a difference between the two. So even though we have a similar pH, we still get different results. Okay, this is a more detailed description of what we think we saw. The dark edge that I showed is probably all the way pushed out here, while we still have microspheres sticking to the glass surface here, or at least in close proximity, and the same at the bottom here. Here, now I will show you quantitative results from our measurements. On this axis we have the real time in minutes, and here we have the easy layer in micrometers. And here we did a trial to see how reproducible we really are. And we did 3 runs, and as you can see, we're very reproducible actually. So, and I show you this slide because in the following you will then see what might constitute a signal and what might constitute just noise. Here is the same graph as the previous one, only with error bars. So this is the size of the error bars. So please commit this to memory for now. Okay, here we have what I would consider a distinct signal. The 4 trials that we had in the top here is Emeryville tap water, and the 4 trials that we have at the bottom here, that is the Emeryville tap water but running through an alkalinizer. And as you can see, the easy layer forms much easier, or goes much farther out and faster with the tap water. And with the alkalinized water, it appears as if it's more viscous. And that is consistent with what Dr. Jerry Pollack said, that we have a structured water, which is more gel-like. So that will confirm this. And since we have our trials, which are so nicely aligned here, we can clearly see that we have a nice signal. Here we did something similar. Again, the tap water produces an easy layer that goes farther out and faster. And here we have carbonate buffer, pH 9.5, which is below, just as we saw earlier. Now we wanted to see what the difference is if we take water and vortex in. Here we have a Niken Pimac vortexer. There are magnetic beads in here. So the water is being vortexed and is drawn in and then being pushed through these baffles here and then goes out. So the water is not just vortex but also going through a magnetic field. And that apparently has some health benefits. And we wanted to see what difference it does. And we vortexed for 20 minutes, and this is the result that we got. We started with the same water, Trader Joe Mountain Spring water. We had the same dilution of beads here, so everything was the same, only we have the black curve is the unvortexed water, and the orange one is the vortex water. Now, while this signal is not all that different, you can still see a general trend that the vortex water produces an easy layer that is a little bit more gel-like. So, and that would go along the same lines what Dr. Jerry Pollack said. Okay, now it's Beverly's turn again.
I should start by saying our laboratory has had a long history of looking at extraordinary human abilities, Eastern practices such as meditation, yoga, qigong interest me a great deal. They help build a real biology looking at the full human potential in health and healing, which is in distinction to the mechanistic biology that Rupert Sheldrake and so many of us have come from but want to move beyond. And so we had a database of human subjects that have worked well with us in experiments, for example, showing stimulated growth of heat shock bacterial cultures in research that was funded by NIH and many other studies over the years. So these experiments are really foundations of energy medicine to understand the modus operandi for how some of these modalities, such as Reiki, therapeutic touch, and projection of Qi, as is done by Qigong masters, may work. Just to mention an interesting study in the literature, not mine, done in Brazil. I like this study because it involves animals, and there's probably not a placebo effect on animals. Many people dismiss results of energy healing on people because they say, well, it must be a placebo effect, you know, laying on of hands. It's a soothing psychological thing. But here, guinea pigs were given drinking water that was treated with therapeutic touch. They were not animal handled, they were simply given water treated by healers. And 10 were given control water to drink. These were guinea pigs that then had skin wounds made with a certain standardized device. And then they studied the healing of the wounds and found that at 20 days, all of the guinea pigs who consumed the therapeutic touch treated water completely healed, whereas only 40% of the control group had healed, showing apparently an effect of the activated water from the laying on of hands through therapeutic touch. So that's a nice basic science study showing maybe there's a phenomenon here. We chose from our database some of our top-notch performers who had done well in physiological studies on showing their incredible physiological regulation of heart and brain, and on some test systems in the laboratory, including, as I said, heat shock bacteria stimulating their growth over control cultures. I'll just describe what we found with respect to water. So these are 6 subjects ranging in age from 36 to 75 years old, different races and genders, practicing, who had studied a number of modalities where it says mixed modalities and developed their own thing. In the case of Qigong, it was an external projection of Qi used in healing, or Kung Fu practice, which is martial arts. And they practiced between 4 and 40 years of these modalities, so they are very experienced. And there's Harry with one of them setting up the easy layer with his device. And some of them placed hands near but not on the slide. They could not touch it, of course, with a jar, and we would see it under the microscope. So they were within about 10 centimeters. There's another one working, trying to influence, and we had them try to influence the formation and the kinetics of the easy layer in various ways. Free form, just play with it, try to speed it up, try to slow it down, try to make a change. So here's an example. I won't show you all the data, but this was, let's see, a control and a couple of actually healing hand runs with one healer. And we didn't see a difference. There was nothing distinguishable. Another one, freestyle control. This is a different person now, and the controls, you can see there's really a superposition of the curves. Another one, let's see, also freestyle, aiming to retard in the beginning. Aiming to retard and then speed up. And in fact, there was a slight appearance of it speeding up over the control curve here. But in the end, it pretty well evened out. There wasn't a significant difference. Also, another form of energy healing compared with control, again, no difference. And perhaps a slight diminution here in this one. The Reiki done by this practitioner looked lower than the control, but again, it was not statistically significant. This one treated with loving energy, sending love to the easy layer, and again, no difference. Okay, so you get the idea. This one looked possibly slightly improved. The subject was thinking flow. And indeed, the curve looks slightly above, the red curve here, slightly above the control, but it wasn't statistically significant. So, all of our data show curves like this with human subjects. None of them were statistically significant, no matter what mode they tried, whether it was Kung Fu, external Qi, Reiki, loving, healing, etc. Okay, now I come to something that I tried to do. I thought, well, maybe let's slow it down. Let's put in some carboxymethylcellulose, which is a known thickener used in the food industry, makes thick syrups and ice cream and things like that. And we put just a very tiny amount in the water. And at the same time, I applied intent and put a Herkimer crystal, thinking, well, maybe that will amplify my intent. But we did not see any difference once again, although the thickening agent, the carboxymethylcellulose, changed the kinetics and endpoint of the easy layer. So you can see there was no distinction between the control and my intent with tap water or tap water plus carboxymethylcellulose, but there was a distinction that was significant between the thicker viscous fluid and the starting material. Also tried amethyst with intent to speed up, no discernible thing. So, in short, we did not see any changes with human intention or laying on of hands. However, let me add that doesn't mean there's not an effect of human intent on easy layers. It means that the way we set the experiment, which also involved optical light illuminating a microscope, might have overpowered anything more subtle that a person is emitting. So I see that we will repeat this looking at electrical potential measurements of the potential difference in the dark. And there will be no glass on top, so we won't have any confounders. Experiments using the GeV I've done for many years. I've had a GeV camera for a long time, and we always find a remarkable effect with intention and energy healing, whether it's individuals or groups. And we use a method called the hanging drop method, developed by Dr. Karatko, and it's simply taking a small syringe and the hanging drop, which really consists of about 10 microliters of liquid. And you can imagine that this is an easy layer because it's a hanging drop and it's exposed to air, and it's also in the dark the way the assay is performed, because we hang that syringe within the machine. This is the GeV camera, and the charge plate is here, and the syringe is hanging down with a suspended drop just a very small distance from the highly charged plate at about 10,000 kilovolts. And then a cover is put on that so that the whole thing is in the dark. And I've had healers treat the droplet with intention as well as bulk water in a beaker and then the hanging drop. And we always get changes. Here's an effective vortexing that we saw with the GeV, the same Niken vortexer. In the control, you can just see it visually, and we can analyze these parametrically, and some of them I have brought with me. We had group experiments informing water over many years now, and most recently we had a meditation group in San Diego, about 1,000 kilometers away, that never did this before but decided to keep us blind. We had 2 sites where the laboratory water was kept. We didn't know which one they were going to treat. We simply measured taking GeV photographs before, during, and after their meditation, where they were currently sending energy and intention for revitalizing and blessing the water. And in 6 out of 8 experiments we found an effect of an enhanced corona discharge, as I showed you. Some of them look like this. Now we're starting with ultra-pure water. It's not as dramatic in the GeV photographs. It has less minerals. It produces a smaller, like a pattern. But after treatment, over a distance, it's hard to understand how does something like that happen. It's probably not energy as we know it. Looking at Qigong masters, and these were some of the masters in the same study as easy layer. The control water, this is a mineral water. Having more minerals, it produces a more sizable corona discharge in the GeV. But post 10 minutes treatment from the Qigong master, you can see visually it's a more expanded profile. And then we analyze the GeV photographs with the software that comes with it. It's called a parametric analysis, and it measures the area in pixels, the controlled and treated, calculates the difference via t-test. The p-values here, 0.0087 is significantly different, a larger one in the treated case. The fractal form coefficient was also significant, increasing. Entropy was not significant, and intensity or brightness was also significant. In this case, decreased. And here's another example, the same. You see a larger current of discharge after 10 minutes with the second Qigong master in the same study. So we do see effects in the water, we just didn't see it. Perhaps the way we set up our easy experiment, visible light and glass may have been confounders. Or there may not be an effect, that's also possible, but here again, p-values in area, fractal form coefficient, and intensity are all statistically significant. So there have been effects seen on water. Many people have seen these using the GDV and some other systems. Finally, I want to talk about UV absorption. The spectrum of water in UV is not very strong, especially between 200 and 400. You don't see a peak at 270 in ordinary bulk liquid water. So we began by taking a different spectra. Of course, pure water versus pure water shows no change. And we used a single cuvette just to rule out any problems that might even come from subtracting unmatched cuvettes. But we did find a very small change from one subject in our study, a apparent peak here, which correlated with 270. A little change here at very low, but it could be air because it's less than 200. So the results in the ultraviolet absorption studies with subjects treating bulk water and then the bulk water in the cuvette or taken into the cuvette afterwards, we only found 1 out of 4 subjects led to a very small absorption peak. Actually, this is incorrect. We did find a small change at 270, and we found a very minor indication of absorption at 210 and 240. We looked at electrolyzed alkaline water versus its starting tap water, but we did not see absorbance at 270, comparing them. Looking at vortex water, we saw an extremely small change, a possible absorption peak out here at 370. It's hard to say there's something at 270, maybe a little tiny hump. I think that's consistent with what you wrote in your book also. So, let me come to our conclusions. I should also say that we ask our subjects to complete questionnaires to assess their level of confidence in the experiment, their affinity for the water targets, and satisfaction with our experiments, because we know that people cannot perform if they're not feeling well integrated in the experiments, and all of the scores on the Likert scale from 0 to 10 were high on these variables. So confidence, affinity for water, and satisfaction with the experiments ranged about 8.5 out of 10 on the average, and that's a good score. So in conclusion, we examined the three-dimensional dynamics and easy formation through microphotography and found that there are layers of movements of the microspheres indicating possible vortices interacting with the glass on the edges, at least in this kind of optical system with glass, with the system encased in glass. We found that ionized alkaline water produces about 28% smaller exclusion zone than the control water from which it's made, and that's not entirely accounted for in terms of pH differences. I should also mention that ionized alkaline water that we use has an oxidative reductive potential of about minus 250 millivolts. So it is electron rich. And we found that vortexing produces a similar exclusion zone as control water, pre-vortexed. We did not see effects from Qigong masters or healers, 6 of them that were our superstars from previous studies. We did not see them altering easy kinetics or endpoint, as seen using the customized optical flow system with image analysis. However, as I mentioned, it could be the overpowering influence of visible light used in microscopy may have overshadowed any influence from human intent or emission of chi, prana, whatever it is that may be happening, and we should repeat these studies with potential measurements at the easy layer in the dark. And we did, however, find from the same subjects human intent and emission of energy, putative energy, apparently affects the GDV photographs of hanging water droplets. And we've done at least 20 subjects over the years, and we find consistent changes, as well as people in groups. Only one subject out of 6 produced an extremely small increase in ultraviolet absorption at 270 nanometers, and there were some other small peaks at 210 and 240. And finally, electrolyzed alkaline water and vortex water showed no significant changes in UV absorption at 270. So we can say that we didn't see a measurable interaction with fourth phase water in our studies, but we did find changes using the GDV camera. Nonetheless, we will go on to pursue this with electrical potential in another time. I'd like to acknowledge the support of the Federico and Elvia Fagan Foundation for supporting our work. Thank you.
I have several comments. First of all, very nice results. We tried also a healer to determine whether there was any impact of the healer, and we found nothing. So consistent with what you found. The issue of enclosing the chamber with a top and a bottom. My friend Felix Blackman in Russia put a student on this, and the student used a piece of napkin with the top and the bottom, and she failed for 1 year to find any exclusion zone. And we had a little chat, and he removed the cover, and then same microsphere, same water, beautiful exclusion zone. So, you know, in thinking about why this might happen, it's possible that the EZ is more dense than bulk water, and you have a sealed chamber. It's difficult to create a vacuum if you go from the water to EZ water. That's just one point, one possible idea. Another point is the reverse flow. We've seen some of that also in some circumstances. You know, in thinking it through as to what might be going on. As the exclusion zone grows, it generates protons, but the protons are not only beyond the exclusion zone, but on the side, on either side of it. And so if you're using negatively charged microspheres, it's likely or possible that those protons on the two edges are pulling the microspheres back. At any rate, if microspheres are moving out, something needs to replace them. Otherwise, you lose volume. And so I think that is a possible explanation for the backflows that you saw. Maybe just a suggestion. I think I'll quit there.
A question for you, though. I'm wondering, do you think there's any flow of water through the naphion? Has anyone ever looked for that, or through the gel?
Good question. It could be. I'm not sure. Yeah, it might be. Yeah. Because naphion is a good so-called proton conductor, so it's possible if you have protons moving through inside the bulk water, and you have EZ water inside the naphion, and some bulk water, the bulk water, they create a channel that goes through the naphion. So you could get flow through the naphion too. Yeah. Anyway, nice measurements.
Well, I also found it extremely interesting. And concerning the pH experiment, controlled experiment that you did, when you changed pH using buffer, you also changed the ionic strength of solution. So I think that perhaps may somehow obscure the result.
We use a very weak 0.03 molar buffer. But I have to mention that we did use carbonate. Now I have some concerns about carbonate in light of Latimer's work.
Yes. And concerning the naphion point that was just raised, way back I worked with a system which was called osmosedimentation. In looking at your results, it came to my mind that the nephew, actually, it should have, well, it is swollen, so it has water inside, and I think osmotic pressure within the nephew should be constant. So actually, it is, it may exchange water with the neighboring liquid. So even if there is no that current across it, well, still out. So even if there is no net current across it through pores, you could consider it as as a water reservoir exchanging liquid.
Yes, Nephium is gel-like and it contains a lot of water. And when working with Nephium, it is also important to always keep it wet. It has different properties if you let it dry out. So whenever we did an experiment, we made sure that we did not start from a dry process. So we always kept it wet and only then took it in. There's the lady in the back.
Thank you very much. I really love your presentation.
Yeah, here's
Thank you. Your presentation was very interesting for me because I was doing similar things lately with the microscope. Only I didn't use napkin, I used metals. So with metals, you can see the same thing, the formation back and forth. So that excludes that flow of the water through metal because it is not possible. So it is not, because I guess it is not the case with napkin also. And my question was for you, did you try maybe to vary the concentration of microsphere in microsphere suspension?
Yes,
Thank you.
We did. We chose a couple of concentrations and we didn't see much difference, I think, between a dilution of 1 to 100 and 1 to 30 from a stock solution. That was a dilution of 1 to 10 from the commercial suspension that we purchased. We didn't see it. It's harder to, there's more stickiness when you have that, and there's more aggregation of the colloid in larger concentrations. And so there's an optimum one for visibility, which is usually a little more dilute.
There's a gentleman in the back.
Very nice talk and lots of great visualization. Tim Crow from University of Georgia area, and we've been looking at electrolyzed reduced water, and we find that it's interesting that if you generate the water with just pure laboratory water, it doesn't really have the ORP, oxidative reduction potential. And I mean, she mentioned only minus 250, whereas we get quite higher when we have, or has more like calcium, for example, or other ionizable capabilities. So could you just comment on, did you look at the levels of your calcium and magnesium?
Right. Actually, we didn't just always use lab type 1 water. I couldn't present all the data here. We did frequently compare mineral waters as well. And the oxidative reduction potential of minus 250 millivolts is from the ionization, putting tap water through an ionizer. And that's comparable to a mountain stream running on Earth. Hydrologists say that would be a mountain stream if you could collect it at the source, but once you put it in a bottle, it will deteriorate. So many of these mineral waters sold have positive electrical potentials. And you know, tap water may have a neutral or slightly positive, but lab type 1 water, which is used throughout most of biology, is really very dead. And you know, you have to add trace minerals and many things to make cells grow.
Thank you.
There's a gentleman in the back.
Thank you, very interesting talk. So I I'm Shirahata, Kyushu University, Japan. I have two questions. In electrolyzed alkaline water, the energy may be stored in EZ water. Do you think so? Another is vortexing. So, not combination with electrolyzed alkaline water, just tap water or other water, vortexing may give some energy.
I'm sorry, I missed that last sentence. What may give some energy? What did you say?
First question is, in electrolyzed alkaline water, this may be hydrogen rich and maybe energy rich. But such energy may be stored in EZ water. Do you think so?
In what water? Oh, easy water.
Easy, yeah.
Well, I don't know about being hydrogen rich, but I certainly think the electron rich is clear from Dr. Pollux and his associates that there is a negative charge to this layer. That's electron rich. I think that's the case.
Okay. So second question. So vortexing, the right-handed vortexing and left-handed vortexing, some difference you can find?
We didn't compare that difference. And it may also depend on the Coriolis force and which hemisphere you live. Who knows? Let's see. We were using a vortex that was counterclockwise. But we did not, we weren't able to make it go the other way, so I can't answer that.
Okay. Thank you very much.
Okay, thank you.